Welcome to my channel. Today, I will dive into an intriguing macroeconomic analysis on real GDP. But first, let's consider three key questions. 1. How do countries' business cycles align during the global shocks? Second, can we detect asymmetric response to major economic crises with new methods? 3. What insights can clustering and alignments reveal about the global economic patterns? In my presentation titled Unveiling Asymmetric Patterns in Real GDP Analysis Through Clustering and Alignments, I introduce a new approach to analyzing macroeconomic time series. This study uses dynamic time warping and a strong internal verification, going beyond traditional clustering methods. Our technique aligns countries with similar business cycle traits, even when their GDP series differ in speed due to the global shocks. By applying dynamic time warping, we can address difference in timing between the real GDP series of various countries. This helps us accurately align the series to reveal the true patterns in economic series. The study looks at real GDP data from European and European countries starting from 2004. The results show a clear asymmetric response to significant economic crisis, offering new perspectives on how different economics react. A key finding of this study is that these asymmetric patterns can guide policymakers and economists in anticipating and managing future economic shocks. By grouping countries based on their response, we can suggest policies that fit each country business cycle behavior more closely. Thank you for watching. I hope this video overview has sparked your interest in using dynamic time warping for real GDP analysis. I presented this work on 7 September 2024 at the International Conference of Applied Economics at Pennsylvania State University Altoona in USA. The full information is linked in the description below, when you will also find the conference website with more talks and detail. Although this channel is mainly in Spanish, the presentation was delivered in English. I hope it helps a wider audience. If you are curious or have any questions, leave me a comment below. I hope you enjoyed the presentation. Thank you. Good morning, everyone. My name is Miguel Ángel Ruiz Reina. I'm a PhD in economics from University of Málaga in Spain. Today I will be presenting our research entitled Unveiling Asymmetric Patterns in Real GDP Analysis Through Clustering and Alignments. We will begin with an introduction to provide the context and background for our study. Then we'll explore the dynamic time warping and clustering for macroeconomic time series, which is the central focus of our methodology. Following that, we will review the data and illustrations, empirical results, where I will share the findings derived from our analysis. After that, we'll move on to concluding remarks, summarizing the key insights and implications of our study. Finally, we will discuss the future lines of research, outlining the next step in ongoing investigation. In this study, we propose a novel approach to analyzing macroeconomic time series, particularly focusing on real GDP. We use dynamic time warping combined with robust internal verification to surpass traditional clustering techniques. These methods allow us to effectively align countries with similar business cycles characteristics, even their economic series differ in speed due to global shocks. Our research, which includes data from both European and non-European countries and covers asymmetric response to major economic crises in 2004, and these findings offer valuable insights for policymakers and economists, helping better understand and address the complexities of global economic dynamics. In this presentation, I will explain the dynamic time warping, how it helps analyze macroeconomic time series, particularly identified alignments, behaviors like recession and recoveries, and DTW allow us to patterns in key economic variables like GDP and investment, providing insights into different countries' response to financial crisis. And we apply this technique to real GDP data from 48 countries, covering the period from 2004 to 2022, to propose a method for determining the optimal number of clusters, ensuring internal consistency within them. For your information, on 19 June 2024, I published an article in Computational Economics entitled Dynamic Time Warping, Intertemporal Clustering Alignments for Hotel Tourist Demand. This work focusing on applying DTW for the field of tourist economics. If anyone is interested in discussing the research further or exploring potential collaborations opportunity, please feel free to contact me. I will be delighted to discuss the possible joint projects or collaboration. In this slide, I will discuss the application of DTW and clustering techniques in the analysis of macroeconomic time series, with a focus on economic growth behaviors across different countries. Traditionally, analysis of countries' economics growth behaviors rely on correlation-based features such as volatility errors or their estimation, as noted Gadea, Rivas et al. In 2018. In contrast, our approach offers a robust foundation for understanding how these results are derived, thereby ensuring both the rigor and validity of our findings. In Figure 1, present the structure of our proposed methodological framework. The process begins with data collection and the creation of the database from raw data. We apply the transformation techniques such as box-Cox transformation to improve data quality and enhance robustness for our statistical analysis. And next, we determine the optimal number of clusters and employ specific methodological techniques, including DTW. Following this, we implement the hierarchical K-means algorithm for classification, and the internal verification is then conducted to assess intergroup or homogeneity and intergroup heterogeneity. If these criteria are met, the clustering is deemed successful, and otherwise the number of clusters is iteratively redefined until the efficiency criteria are defined by the researcher are satisfied. In this slide, we focus on two key points. The most important thing is to understand the short formula. K is the number of clusters, and M is the number of countries that we have time series data for. And to find the best number of clusters, we use a simple formula. K is equal to 1 plus log base to M. And this helps us to group the country's efficiency based on their economic data. And in this slide, I'm showing an example of real GDP for rates for Italy and France. As you can see, their time series their time series follow a very similar behavior or patterns over time. We use the DTW to measure the similarity between them, even if there are slight shifts in timing, and DTW helps align these two time series as closely as possible, showing how similar the economic trends are. And this slide explains how we verify the clustering results. When the value of cluster internal verification method is close to 0, it means that the elements within a cluster are very similar. On the other hand, when the value is close to 1, there is greater diversity within the cluster. Internal verification allows us to understand how similar the elements within the cluster are compared with the median, In principle, it is a mathematical strategy to verify the correctness of the group and to ensure that there are no outliers. However, in economic terms, it allows us to see whether there are significant difference between countries among countries and their response to crises, recessions, or economic growth. Here we have the data from the Federal Reserva of St. Louis database comprising 3,648 observations from 48 countries spanning from 2004 to 2022 expressed in quarterly data. It includes the major economies such as USA, UK, and Japan, as well as emerging markets like Brazil and India, with a focus on real GDP growth rates. And we used our methodology to analyze the GDP data, starting with 2K iterations. In the first iteration, some countries were excluded, and in the second iteration, cluster 6, here we have, cluster 4, cluster 5, and cluster 7. And cluster 6, which contained only one country, was removed. Some key findings. First, let us examine the shaded areas in the graph. The one on the left in each chart represent the global financial crisis in 2008, and the one right represent the COVID-19 health crisis in 2020. And this allows us to initially identify the major historical shocks and the response of the various countries analyzed. During the 2008 financial crisis, GDP declines were under 5% across all clusters, with cluster 1 and cluster 3 recovering faster. As you can see, the recovering was faster. And Estonia and Lithuania in cluster 4 here experiences the largest GDP contraction, exceeding 10%. Okay, the COVID-19 crisis here and here, here in the right on the chart affected all clusters, but in cluster 2, including Iceland, Saudi Arabia, and Latvia, recovered more swiftly with a less impact. For example, here, and cluster 3, which includes UK, Canada, and others, saw the most severe declines but exhibit a strong rebound afterwards. This analysis highlights how different countries responded to global crises and demonstrates the effectiveness of our clustering method capturing these variations. Figure 4 illustrates the box plots for internal verification across the cluster. These box plots provide a clear depiction of the distribution and variability within each cluster based on DTW alignments. And cluster 4, 5, and 7 are equidistant from the contemporary median, simplifying comparison among them. This cluster demonstrates a relatively high degree of consistencies in their internal verification metrics, suggesting a moderate level of uniformity within each cluster. In contrast, in cluster 1 and cluster 3, which are larger, exhibit a greater intercluster diversity, as you can see here and as you can see here. Shows a diversity, and the box plot strength in cluster 1, for example, is close to 0.5, with some outliers are presented, for example this point and some outliers, indicating a notable variability within the cluster. And finally, in cluster 2, is notable for the length of the whisker in its box plot, which reach up to the acceptable limit of 1. This is the limit of acceptable internal verification clustering. And in summary, cluster 4, 5, and 7 exhibit high uniformity, while cluster 1 and cluster 3 display greater internal variability. Cluster 3 showing the most pronounced heterogeneity, and cluster 2 is characterized by a broad range of diversity, albeit still with an acceptable threshold, because the number is less than 1, as you can see here. For the concluding remarks, in this study, we applied dynamic time warping to macroeconomic time series, showing its effectiveness in clustering and verifying consistencies through alignment. DDW proved to more dynamic and efficient compared to traditional regional analysis methods, particularly by focusing on real GDP variations. Our analysis covered 48 countries, including major global economies like USA, Japan, or Korea. And this method aligns well with our framework, helping policymakers better understand economic cycles and response to crises. By clustering, we identified diverse reactions to K crisis in 2004, providing insight for more informed decision-making. And in summary, this approach offers a valuable tool for economic planning and helps address the varied impact of global crises. For the future lines of research, moving forward, we are focusing on expanding our dataset to improve the consistency of the clustering models across the more scenarios, and we are also exploring alternative clustering criteria to refine the model for greater accuracy. And additionally, we are working on enhancing the computational efficiency of our algorithm in R programming. This will allow us to handle larger data sets more quickly, making the methodologic and more powerful for economic research and decision making. For the conclusion of this presentation, I would like to extend my gratitude for everyone for your attention and interest of our work. And thank you again for your time and your attention. I'm looking forward to any questions or feedback you may have. Thank you.
Okay, thank you, Dr. Miguel. So I'm going to be your panel discussant. Okay, so far, congratulations, Doctor. It's a very good paper, alright? So you explained about the novel macroeconomic time series approach, okay, using DTW. And a robust internal verification, okay, and also some clustering techniques, okay. And you also mentioned just now that your method effectively aligns, okay, with countries with a similar business cycle characteristic, even when their series differ in speed due to global shocks, okay. And also based on your analysis just now, okay, you demonstrate the efficacy with the real GDP from the Europe and non-Europe countries, and also you explain about the asymmetric response to major economic crisis since 2004, and also you provide some insight, valuable insight to the policymaker and also to the economists. So congratulations, Dr. Miguel. I have two questions. Okay, I just want to get some explanation from you. How Dr. Miguel, can you hear me?
Yeah, I hear.
Okay, alright. So how you select all those 48 countries? How is it? 48 countries?
I select 48 countries. The main reason was the disponibility about the data. I would like to stand for every country in the world, but I have only catch only 148 data for time series from 2004 to 2022. I would like to extend for more countries, but the main limit is the time series to be disponible, to be available.
Okay, but I can see that you touch. I mean, you have a representative for each region. You have Europe, including Asian, including
I got it. we have a problem with the available of data, and if you have data and you can send me, it's okay.
Okay, and then the second question. Okay, how you put all these 6 clusters? How you make it cluster from these 40 these countries? How you cluster it into 6 clusters?
Okay.
What is the
Okay.
Do you have any standard requirement? Or?
Okay, I will share my screen. I think it's better. The main problem. Sorry. I will share the paper. Okay. The main problem in this type of investigation or in the literature review is to select the optimal number of clusters. In particular, they are not very clear in the literature review, and I have developed this short formula that I said before that I published in Computational Economics. And this formula helps us to decide the optimal number of clusters. Probably it's not the best, but it's a mathematical solution about our problem. And the main reason to select the number of clusters is how many, in this case, how many countries you have. For example, N, capital N in this presentation is number of countries, and we have 48. For example, I'm working in different fields. For example, in tourist economics at the moment, I have 200 localizations, and in this case will be 200 localizations. But the problem at the moment is that I have only 48 countries. And using this formula, I select 7 clusters, only calculating this issue. Okay, and after I decide if the cluster is well doing using the internal verification here. The internal verification here, and we decide if the selection is correct using box plot. I will explain the box plot. And using the box plot, you can see here better, is the limited that you can say is the acceptable limit to decide if it's okay, it's right, the clustering process. For example, here this is the limit, and here, and here is so far to the number 1, as you can see. And here you have more data that represent outliers in the clustering process, for example. I don't know if I respond your question.
Yes, you already answered my question. Thank you, Dr. Miguel. Okay, I'm open to Dr. Lazos and also Dr. Magomed. Do you have any question to Dr. Miguel?
No.
No. Okay. Dr. Konstantinos Lazos, you mute. Please unmute your speaker.
Yes, we can. Well, I have just one suggestion, maybe for to extend your research. Since one of the major objections for the European Union was the asymmetries concerning the different countries, the north, the south, etc.
Yeah.
And I was wondering whether you could see, in particular, with the European Union, whether these asymmetries were increased in time or were decreased in time, especially as the European Union enlarged, etc.
Okay, thank you for your question. In this case, we solved the problem, the asymmetric response to different economic crises, using the Bosch-cost transformation. In particular, we are expressing every real GDP in rates because we express in percentage. Because every country has different response, has different currency, has different problems, has different particularities, and we use box cost transformation to express every growth or every recession in percentage. As you can see, here, we compare different countries with different situations, with different currencies, and with different political results of every political decisions, and we can compare using the time series in percentage.
Okay, Dr. Miguel, one last question. Do you include any theories in your paper?
Okay.
Any theories?
Okay. For economic applied, probably everyone could ask what is the theory in economics. This is a paper that we use data science. What is the data science? We use methodological, statistical methods to understand the reality about the economic growth for 48 countries, and this is a limitation at the moment. This is the limitation at the moment because we haven't the causality. But now we know how the different countries could align through the time. But we are working in causality. This is the first step about our investigation. But of course, we should work in the causality.